Good morning, good afternoon, good evening. Welcome to WFI webinar. Today's topic is cleaning air solutions during a global pandemic. I'm Christine Song, President of Waterloo Filtration Institute. I'm very excited that we have three distinguished speakers, leading experts from the field. Dr. Thomas Caesar of Frunenberg Filtration Technologies from Germany, Professor Paolo Trovio of Politecnico di Torino from Italy, and Mr. Steve Nickness of Air Industry Technical Services from the US. We are also honored to have four distinguished area experts in the panel today to help address your questions. Professor Dai of Vanderbilt University Medical Center, Ms. Brown of Olin Press, creator of Vogue masks, Mr. Bob McVeigh of the McVeigh Company, Ms. Kathleen Owen, current ASHRAE 2052 chair and ASHRAE fellow. Thank you all for your great support and contribution as we work together for public safety and health during such a global pandemic. Here's the agenda for today's seminar. We have three great presentations. We will take a 5 minutes bio break in the middle after our second presentation. Please put all your questions in the Q&A box during the presentation. We will address all the questions in the final question and answer and panel discussion session. We have to acknowledge WFI members for all their support. We are not able to have such kind of education program without their support. So thank you so much for all their support from the very beginning last year. Move on to our first topic today by Dr. Caesar, cleaning air during a global pandemic. Dr. Caesar is a very well-known leading expert in the global filtration industry, a colleague and a great friend. Now working at Frunenberg Filtration Technologies as Director of Global Filter Engineering Industry Filtration. We are so honored to have you here today, Dr. Caesar, with us, with all his experience and also a lot of activities going on to support all the needs during this pandemic time. So Dr. Caesar, the microphone is yours.
Yeah, thank you, Christine. Thank you for introduction. So first question, can you hear me?
Yes.
Okay, perfect. But that was the wrong presentation. Yeah, so next slide, please. So when we talk about cleaning air and air filtration in a global pandemic, first thing, of course, we have to look at and to take care of is what size ranges for the virus we talk about are we talking and are we looking at, and then also what distribution routes does the virus take. So in this diagram here, you see a little bit the size comparison to a human hair. And I tried to also put a picture of the virus on here, but even in that scale where the human hair is almost like a part of a tree, it would have been so tiny that you couldn't even see it here on the screen. So basically, when you look to Wikipedia and when you research on the internet, you find different statements about the size of the SARS virus. But basically, it's somewhere around 100 nanometers. Wikipedia tells you 60 to 140. In other, you find 80 to 160. But let's say around 100 nanometers, roughly. That's the size of the coronavirus. But typically it doesn't travel on its own through the air. Typically it's attached to some particles, to some droplets that are generated by snoozing, coughing, and so on. So basically the relevant size range we are looking at, because these droplets may have various different sizes. So the relevant size range we are looking at is basically PM2.5, the inhalable aerosol that may contain the viruses or multiples of viruses. Somebody has his microphone on, so please could you mute, please? And also to be on the safe side, when we look to filtration, I will come to that later on. I think PM1 is a good representation to look at the filtration efficiencies and to be on the safe side when it comes to the filtration of the virus. Next slide, please. So what are the transmission routes of the SARS virus? So first of all, it's micro droplets or aerosols, which basically stay airborne for quite a long time. So we are looking here at particle sizes which are not sedimenting very quickly, so very small particles. Then second route is larger droplets, so directly what you snooze and cough and talk. Particles which basically sediment within a short time. That's why keeping distance with 1.50 meters typically recommended is effective to protect against these larger droplets, the direct contact with these larger droplets. But the SARS virus is also transmitted via surface contact, so the so-called smear infection, so hand by surface. Depending on the surface material, it may stay for hours on certain surfaces, and then you can get it on your hand, and then by touching the face, the nose, the eyes, it can get into your body and infect you. Not so much discussed and not so well known is the fecal oral route. So also through toilets, the virus can be distributed. I will come to that also later. Next slide, please. So when we talk about it, and basically everything is about minimizing the infection risk. That's the aim, whether it is distancing, whether it's hygiene measures, whether it's wearing mask or filtration in the building, it's always minimizing the infection risk. And I've put here on the slide, complex tasks require multi-stage integrated solutions which build on each other. And that is basically the key of the whole presentation I'm giving here, that not one individual measure does give a sufficient protection against the virus. It's the combination of various measures, and only all together then really minimize the infection risk to a low level and give a kind of good protection against an infection. And basically coming back to the different infection routes, which I already showed. Of course, there's the direct infection route from one person to the other. That's where the keeping distance and wearing face masks really helps. But also, of course, when it comes to the infection by contact of surfaces, hand washing, hand hygiene, or hygiene in general, all the social distancing and everything is basically the first thing that keeps you away from the direct infection. But then, as we have also seen, these droplets that you snooze out or cough out, they can dry out, they can basically get much smaller, they can stay airborne for quite a long time, and by that also be distributed with the air through a room, through a building, also with the ventilation system. And that is basically where then the air filtration comes into the game. And at the end of the day, when it comes to room air, it's all about dilution of the the contaminated room air, the room air containing viruses, diluting that with clean air to reduce the virus concentration to an absolute minimum. That's also what I will talk about later on. So basically the combination of all these measures That is what gives you a sufficient protection and not one individual measure on its own. Next slide, please. So first of all, to avoid the direct infection, face masks are very well known meanwhile in the public. I guess that's globally everywhere more or less the same. Here in Germany, when you want to go even sometimes out of the street or at least in the supermarkets or to work, you have to wear face masks. And there are different types of face masks on the market. One are the respiratory masks. Then the second category are the surgical or medical masks. But also specifically in the beginning of the pandemic last year, as there also have not been sufficient masks available, people were also wearing very ordinary cotton masks, which have no classification at all and could be kind of classified into the decorative mask area. Next slide, please. So when we look at the different types, there are different standards around in the world for classification. And also these masks have different purposes or come from different areas. So when we look at the respiratory protective devices or the FFP mask, the filtering face piece, filtering half mask, whatever you like to call it, that's coming from the personal protective equipment, basically to protect originally people from dust when working in heavy environment, drilling, cutting, or working on construction sites and so on, to avoid inhalation of dust. But of course, it also protects from inhaling aerosols containing microorganisms or viruses to a certain level, of course. In Europe, we have a test standard EN 149, which basically describes how these masks are tested and also give the classification, which in Europe is FFP 1, 2, 3. I will come to that in a moment. So the primary task of these masks is to protect the wearer. Next slide, please. Unfortunately, when you look around the world, there are different standards for the filtering face pieces or respirators. In US, you have the NIOSH standard. In Europe, as I already mentioned, we have the EN 149. In China, there is a GB standard. And all these masks at the moment in Europe are on the market. So basically, you find N95, you find FFP2 masks, or you find these KN95 masks, which are basically the recommended protection levels depending on the different standards. When we look at the filtration efficiency, it's almost the same. It's around 95%, 94% for the European standard. But the test aerosols are quite slightly different, at least. It's mostly NaCl, but in the European standard at the same time, it's also paraffin oil. Also in the Chinese standard, paraffin oil is used, but then that gives a different classification. In Europe, you have to test against both aerosols, NaCl and paraffin oil. The flow rate is slightly different in the European standard. It's 95 liters per minute, while the Chinese and the US standard have 85 liters per minute. And there are also requirements for the total inward leakage, like a maximum of 8% in the European and the Chinese standard. In the US NIOSH standard, as far as I know, there's no requirement for the total inward leakage. And that is basically tested by some human subjects, some test candidates, performing various different exercises, and then during these exercises, the inward leakage is measured. And of course, there's additional requirements like the inhalation and exhalation resistance. If there is a valve, there are different levels of valve leakage described, and so on and so on. So these standards are quite lengthy and the test is quite complex. I just wanted to mention here the classification and the main parts of the classification. Next slide, please. So the next type that I mentioned are the surgical mask, medical masks, mouth nose protection mask, however you like to call it. Their purpose, because they are coming from the medical area and originally they have been developed to protect the patient from the bacteria or microorganisms coming from the doctors, the medical nurses, and so on. So it's primarily to protect persons around in the surrounding of the wearer. In Europe, there is a test standard EN 14683, which basically also describes the classification of these masks and gives also different types or classes of these masks. Next slide, please. The test method of the medical mask is quite different to the test method described for the FFP or the N95 masks. Here, a bacterial solution is sprayed on the mask or is sprayed into the airflow and then tested with the mask. And you have the so-called bacterial filtration efficiency, which is measured. And also the breath resistance that's similar to the FFP mask, but with very different values. But also microbiological purity, the biocompatibility of the mask is tested. Next slide, please. There's also different classifications. Yeah, next slide, please. That was a mistake here. Yeah, when you look at the medical face mask, typically you have a 3-layer design, maybe sometimes also 4-layer design. So there is a spunbond carrier, then there is a functional melt-blown core layer and a spunbond cover. You have a nose wire to make sure that the mask is kind of airtight around the nose, and you have the elastic ear bands. When you look at the FFP mask, they have a quite similar design of the filter media. Very often there you have 2 melt-blown layers. Of course, they are much more in shape because for the FFP mask, it's also quite important that, or more important, that they are airtight around the face. But the principal design of the filter media is quite similar. Next slide, please. Yeah, and then as I mentioned, specifically in the beginning of the pandemic and since a couple of weeks in Germany, you have to wear CE certified masks which follow either the EN 149 or the medical mask standard. But nevertheless, you still see some people wearing also the cotton mask, the so-called community masks, as they also have been named. Which basically have no claimed protective level. There is no test standard available for them. And of course, also in Europe, no CE mark. Next slide, please. So that was a very brief and rough overview of the face masks. Of course, you could talk an hour only about face masks and their effectiveness. And also there are big discussions whether the FFP mask or the medical mask is better and which one to wear now in a pandemic. But that's for the moment all about the masks. And then the next part I want to talk about is the air filtration in the building, because that is also a second thing important to look at. With a mask, as I mentioned, we basically protect from the direct route of infection, but then with the aerosols, The virus can also distribute throughout the room air and throughout a building, and that's where the air filtration in the handling units come into the game. Next slide, please. Yeah, I already mentioned the different infection routes. That's just for repetition. So now we are basically looking here at the first route of infection, the micro droplets that stay airborne for hours and can be transported for quite a long distance. Next one, please. Yeah, interesting point is, and that's why I'm showing this slide here also, is that mostly people discuss about the face mask or they discuss about the building ventilation. Interesting point is also that this fecal oral route is also quite something to look at. And that is where from REVA, the guidelines, the European organization from the heating and ventilation engineers, basically have also addressed with some guidance of how to operate sanitary facilities, where it is quite important to flush the toilets with a closed lid, for example. Of course, water taps should be installed with sensors for no touch use. That's basically where the smear infection also comes into the game. Of course, all the water taps must be in operating conditions. All toilets should be flushed from time regularly and frequently, and it should be ensured that floor drainage does not run dry to avoid open connection to the sewer. So it's also quite, and also one important point is that in toilets, other than in other rooms, windows should not be open to maintain the right direction of the mechanical ventilation airflows and to make sure that air is not going in the wrong direction. Quite interesting point to take care also about the sanitary facilities to prevent virus infection, while mostly we look only at the ventilation system and the face masks. Next slide, please. So basically, I don't want to go into all the details. Part of what I'm showing now is basically given in the REVA guidance. I think quite a good and comprehensive guidance document, meanwhile in its fourth version, which gives a lot of guidance and hints how to operate building facilities, but mainly the HVAC systems during times of a pandemic and to prevent the spread of the coronavirus throughout a building. I've put the link to this guidance on that slide. So if you like to look at it more in detail, please go to that website, and you can. It's basically they're available for free download, so everybody can look at that. Next slide, please. So basically, when we look at the indoor air and the air filtration, first question, and that's typical question we also get very often, can we filter the virus? Can filters work here, and so on. So the first point to look at is the biosafety levels and the requirements for laboratory and containments to handle virus. How do they work? That's the first thing to look at. So next slide, please. So when you look at the, in Europe, you have the EN 1228 for biological laboratories, and there basically different levels of biosafety are defined. Typically, you have biosafety level 3, which is also the level which includes the SARS-CoV-2 virus, which is laboratories following this biosafety level are basically the ones used to research, diagnostic work, and so on, to handle microbes and viruses, and including the SARS virus, as I mentioned. And then the next higher level is the next, please. Just tap one more. Yeah, thank you. The biosafety level 4, that's basically for even more severe viruses like Ebola or the Marburg virus, with a much higher fatal rate. And when you look at the regulations and recommendations for these laboratories, there is no magic in there. It all comes like with classical cleanroom technology. It's all about airflow and using HEPA filters at the right stages, H13 or H14 HEPA filters. So when we look at the SARS virus, it's basically an H13 or H14 filter that gives sufficient filtration level to filter the virus out, and there is no magic about that. And when you look currently at the market, new technologies are rising like mushrooms, and sometimes it feels like we never dealt with viruses before. It's something totally new, which of course is nonsense. Infiltration with deal with bacteria and viruses for decades. It's nothing special and nothing new. And in my opinion, also no need for special treatments of filters with whatever chemicals, which may be more dangerous than the virus itself. Or I've seen people now working with tungsten and UV lights and whatever stuff. And sometimes I ask myself whether the death rate due to such technologies at the end of the day will be higher than from the virus itself. So classical filtration is doing the job. And that's what we should look at. Next slide, please. So, and when we look to the size of the virus, I've already shown it's around 100 nanometers. That's the downside when we talk about classical filtration. Unfortunately, the virus, not in the diagram, but when you look to classical H13, H14 HEPA filters, typically they have their MPPS in the range of 120, 150 nanometers. So the coronavirus is close to the MPPS, but nevertheless in Europe we're testing at MPPS, so an H13 or H14 HEPA filters also gives this protection level of 99.95% or 995% at the MPPS level, so also for the virus itself. Next slide, please. So basically the answer I've already given. We can filter the virus with a very high efficiency using classical mechanical HEPA filters in the HVAC systems. But of course, also the building needs to be in the HVAC system, needs to be designed for that purpose. And that is typically only the case when you look at clean rooms, pharma labs, biolabs, and so on. General ventilation system, you will face the problem that a classical HEPA filter will have a too high pressure drop. And if the pressure drop is too high, first of all, the fan might not be able to handle this pressure drop. Secondly, even if it can handle this pressure drop, it may increase the leakage rate of the ductwork, which then in the worst case can even make it worse. The leakage rate of unfiltered air is getting higher and too high. And so you get more unfiltered air in the building than filtered air. So how about general ventilation in ordinary building where we cannot install an H13 or H14 HEPA filter? Next slide, please. Yeah, and when you look at the building, here is an example of a hospital, but could be also an ordinary building. There are different priorities of ventilation measures we should do. Because at the end, as I showed in my first slide, second slide, it's all about diluting the contaminated air with fresh air. That can be done by the building HVAC system without recirculation. So normal state-of-the-art systems following the Eurovent recommendations for air filtration and how to design air handling units are good enough to give sufficient amount of ventilation of fresh air into the building. And if there's no recirculation, if we only ventilate the building with outside air, the outside air can be considered as virus-free unless there's somebody snoozing or coughing directly into the air intake. But basically, in typical levels where we take the intake air for the building, we can consider and assume it as virus-free. So if the HVAC system cannot be put to no recirculation mode, if recirculated air is necessary for whatever reason, specifically in winter times, in the US, I hear you have some very cold temperatures at the moment in certain areas, and people who don't want, or even the heating rates may not be capable to handle only fresh air. So you have to run at recirculated air, but then you have to make sure that the recirculated air is filtered at a minimum by an ISO EPM 180% filter. Better, of course, with an H13 HEPA filter, but as I already mentioned, there might be limitations to that recommendation. But an ISO EPM 180% filter should already do the job. If there is no ventilation system available at all, or not operative or whatever, then permanent window ventilation, of course, is an option. Might not be the nicest option in winter time, but if there's nothing else available, that can be done. If room air, if window ventilation because of freezing temperatures outside is not possible, then room air cleaners, portable room air cleaners that you set up in the room and that basically recirculate the room air through an air filter can be an option to filter out aerosols and to reduce the aerosol, and by that the virus concentration. Or temporary window shock ventilation might be also an option, but the least preferable option compared to the other ones. Next slide, please. When you look at the typical HVAC system, it's shown here in a systematic sketch. On the left side, you see on the top the intake for the outdoor air, of course, connected to ductwork. On the left side, you see return air coming from the building, coming from the rooms. There is a mixing plenum where basically outdoor and return air are mixed. Typically, the ratio can be controlled by flaps, which can be opened or closed. Then you have the pre-filtration levels. In the latest Eurovent recommendation, that should be during the pandemic, it should be an ISO EPM 150% filter. Then you have the thermodynamic conditionings, the fan, and then the final filter stage. And as this system here, as it is shown, works with recirculation air, it should be as a minimum an ISO EPM 180% filter on the recirculation. Next slide, please. When we look at Europe and the Eurovent recommendation 423, there are recommendations given for the general filtration efficiencies in a building. And typically and in general, without not looking specifically on pandemic times, but in general, we have 5 different supply air categories. Supply air 1 is like for hospitals and similar buildings with very high hygiene requirements. The general building with permanent occupation is supply air 2, and then supply air 3 to 5 are basically industrial buildings with production halls inside and so on. Specifically, supply air 5, for example, is then heavy industry, metalworking, and so on. During pandemic times, we have basically said that in a general building, we should, for safety reasons and to be on the safe side, we should look at the worst outdoor air condition, which is ODA 1, 2, 3. That is basically what we define typically in Europe and different outdoor air levels. ODA 1 is relatively clean air you would find on a very nice countryside. ODA 3 is heavily polluted air inside of a city, and that is basically what we said we should look at for to be on the safe side during the pandemic times. And then the minimum recommendation is in a 2-stage system, an EPM 150% and an EPM 160% in the second stage, or an overall system efficiency for the whole filtration system, whether it's 1 or 2 stages or 3 stages, maybe, should be an EPM 180%. Next slide, please. So, and then recommendation for the building ventilation, use high efficient mechanical filters. That's basically state of the art, following the Eurovent recommendation as I just described it. Fresh air typically does not contain coronaviruses, so if you ventilate the building with only fresh air, no recirculation, you should be on the safe side. And if recirculation cannot be avoided, use high efficient mechanical filters in the recirculation. And here I think an important point to look at is the multiple passes that you have when using a filter here. Typically, when we talk about filtration and building ventilation, we mostly look only at the so-called one-pass efficiency. So air passing one time through the filter, and then what's the efficiency? Here we have to look at multiple passes in the recirculation, and with an EPM 180% filter, if you assume an air exchange rate of 5 to 6, with 5 passes through a filter, EPM 180% filter, you are already at a total efficiency of 99.97% that you reach after 1 hour and 5 passes, which is already also quite high efficiency level for filtration. So here, the multiple passes in the recirculation mode really helps, and that's why an EPM 180% filter is already doing a quite good job there. Next slide, please. And then last but not least, just one brief slide about the room air cleaners. There's also, of course, different sizes of room air cleaners on the market. You find probably thousands of different devices that are offered, from very small volume flow rates up to very high volume flow rates. The example here I'm showing is one with 2,500 cubic meters per hour, or recommended flow of 1,200, but the maximum is 2,500, which can be used also in quite large rooms. There is an F7 and H14 filtration installed. And when you look at test results for that, that was done at the university in Germany, basically measuring the aerosol concentration in the building over the time, you can see that within 1 hour, you have a quite nice decay of the aerosol concentration in the room. So room air cleaners can do a job here, but of course, we have to look at the volume flow rate, which has to be sufficient and has to fit to the size of the room. And of course, if you have a 10 square meter room, that needs to be another device and a different device to a device which you set up in an 80 square meter room or a 40 square meter room. So you have to look at the size of the room and the ventilation level, the volume flow rate supplied by the device, and of course, the filtration level that is installed, that there is high quality and sufficient efficient filters installed. Next slide, please. Yeah, that is basically already my last slide, just summing up what I said. So most important message of this presentation is that there is not one measure giving you sufficient protection. It's always the combination of all the different measures that only in that combination gives you a good reduction of the infection risk to a low minimum. And that is the social distancing, the hygiene measures, the face masks, and then everything I said about ventilation. And if we use state-of-the-art building ventilation systems operated in the proper mode, then also this should give a good protection level together with the other measures. Or if not available, then room air cleaners with HEPA filters are also doing quite a good job. And again, none of the measures on its own give you sufficient protection, only when combined. Thank you very much.
Thank you, Dr. Caesar. Perfect timing.
Thank you.
Move on to our next topic, universal method to evaluate the performance of face masks by Dr. Paulo Tranville. Once again, If you have questions, please put in our Q&A box or chat. We will address all the questions during the panel discussion. A little bit.
Okay, Christine, can you hear me?
Yes, we can hear you. So a little bit background for Paulo.
Yes.
Let me introduce a few words, okay? So
yes.
I first met Paulo at ASHRAE meetings years ago. All these years, he has been so actively involved with standard development research, and I learned a great deal from Paulo. And he was the chair of ISO TC 142 cleaning equipment for air and other gases from 2005 to 2016. And over the years, I see Paulo's passion and also dedication to all this air filtration standard development and also the technologies. So we are so grateful for all the hard work and the contribution Paulo has been made to the air filtration industry. Paulo is an ASHRAE fellow and also a distinguished lecturer. So Paulo, we are so honored to have you here. Please take over the microphone.
Thank you, Christine. Can you just confirm that you see my screen, the first slide of the presentation?
Yes.
Okay. So I think that Dr. Caesar covered already most of my first slide, because I will present some work that we have been doing here at my university in the lab, and also together with other colleagues in developing a way to test face mask, community face masks. But let's start dealing with the purpose why we are using face masks. We know that have two different purposes. As Dr. Caesar explained, actually there are both personal protection equipment devices and surgical masks. They have different purposes. However, people many times they forget actually, and they think that by wearing a surgical mask, or even worse, a community face mask, they are protecting themselves. As a matter of fact, the purpose is exactly to protect the others from us in case we are contagious. And the point here, in order to establish a valid test method, is to understand what is the size range and the performance that we should investigate. And there are several studies that I will not spend time here dealing with, that they're actually describing the emissions from human breath, not only coughing or sneezing, but I would say mainly breathing, which is, that of course, something that is unavoidable. And therefore, if we emit particles by breathing or by talking, then it will be very likely those particles are suspended in the air. However, in this case, it's not clear why there is a part of the community, especially physicians, who actually they don't believe much that aerosols can be effective in spreading the infection. And that may also explain why there are some hesitation in prescribing some minimum values for the efficiency of these face masks. We can see here in this table the three kinds of face masks that we already discussed, and the test methods that are normally used to assess their performance. In the case of surgical masks, we know that they are adopted for ensuring to avoid the particles emitted by the wearer will infect the people that are in the same room, or in the case of a surgical room, the patients that is being operated. And actually, this is the most recommended device in case people are infectious and therefore can also spread the contagion. On the second column, we can see the so-called respirators. There are different types. However, some of them, they have valves on them, and therefore they are not protecting the others from us. their intent is to protect the wearer from the contaminants all around. In fact, they are used in a work environment as a personal protection equipment, and their test is fairly complicated, especially the EN 149 prescribes several tests, not only on the mask but also on the people who are wearing those masks, and therefore it's a fairly long and difficult process. In the US, this is regulated by the law, while in Europe we have a European standard. In China, there is the GB 2626 in the two versions, the 2006 and 2019, which is the 2019, by the way, is not available in the English version, so official English version. So not always easy to deal with that. And finally, due to the shortage of the other two devices, in the last few months, we have seen on the market the availability of many of these so-called community face coverings or community masks. In SEN, it has started the work to standardize the way in which they should be used, and also the way in which they should be classified, or at least provided some information about their protection level. However, again, also like for surgical masks, also these kind of devices are not providing any evidence of protection for people wearing them. However, they are mandatory, at least for instance in Italy, because it is required people not to spread the contagion, and most of the people who are doing that, actually, they are not aware of being contagious. So this is the problem. So, and just a few days ago, ASTM published a new standard, the F3502-21, which is actually dealing exactly with this kind of masks. While in Italy, we have developed a method that is very similar, as we will see, to the ISO 16890 and the ISO 21083 series as a rationale. So to assess the performance of community face masks, first of all, we have to evaluate the efficiency, because this is something that it's the reason why the face mask is actually worn. And at the same time, also the resistance to airflow is very important, not only because it should be as comfortable as possible, but also because, as we can see in the figure, the flow can actually deviate if the airflow resistance through the fabric is too high, and then enter from the leaks. The prevention of leaks is something that is very difficult, especially because most of the masks that are sold today are supposed to be fastened to our ears and not behind the head, like in the case of the classical personal protection equipment that is sold, at least in Europe. So just to give an overview, we developed a test method and classification system. And you see the part 2, which is on the right column, actually specifies the way in which the efficiency by particle size and the airflow resistance is measured. The test rig is very similar to the ISO 21083 one, the one that was developed to test a flat sheet of filter material or filter media for removing very small particles, nanoparticles. However, the test rig can be used almost in the same way, also for the sake of measuring towards much larger particles. Like in this case, we are measuring between 0.3 and 10 micrometer. As a matter of fact, by using a suitable optical particle spectrometer, we can go down to 90 nanometers, or there is an option also to go below in case you you can use an instrument that is able to detect even smaller particles. However, there are some implications also on the aerosol generation. So for the sake of characterizing the removal, the particle removal ability of these masks, the size range between 0.3 and 10 micrometer is very nice, and also takes care of the size range which is more likely to contain the virus. The basic size of the virus, the coronavirus, is 120 nanometers, this is reported in the literature. So we can be sure that all the particles containing a virus will be larger than that. So starting at 300 nanometers is a reasonable way to assess correctly the ability to remove the virus, even when it's in its smallest form, because some kind of mucus, water, or salt is supposed to stay together with the virus. One thing that actually it's important for this kind of test is the ability to qualify also the test rig. This, of course, is very common in general ventilation test methods, but in the current test methods for assessing the performance, both surgical masks and personal protective equipment, this is not that common. And moreover, also, since some of these masks are, they claim to be washable, to determine what is the residual efficiency after the washing cycle, an IPA vapor exposure can give a clear indication about the importance, the relative importance of electrostatic charge for this mask. Of course, if we're speaking of fabric filters, this will not be actually relevant. Then the part one actually put together the information that is taken from the size measurements, the efficiency by particle size, and summarizes that in a size range between 1 and 3 micrometer. This is just actually the proposal that is being used in Italy, but as you can imagine, it's very flexible because it's easy to change it. And according to the approach of ISO 16990, depending on whether the particle size distribution is known or is different from the one that is supposed to be in this reference practice, then it can be changed accordingly. You can see here the test rig, the block that are making up the test rig. It's a common one for those who are familiar with the filter testing. So cleaning the air, injecting a controlled aerosol, which is DHS, which has the big advantage of not, it doesn't need to get neutralized for the sake of measuring the efficiency. And then, of course, sampling upstream and downstream multiple times, it will be possible to obtain the efficiency and associate also an uncertainty value to that measurements. This, of course, it will be completed by a final HEPA filter and the exhaust fan. And this, as you can see here in this picture, there are a few examples of devices that can be tested. And it is interesting to note that on the adapter plate, we were able also to adapt in one case also some metallic sintered materials or whatever can be fit into the test section. You can see also some community face mask with some fancy pattern on them, and also some 3D printed face masks with a very small filter area. So you can imagine that the airflow resistance in that case was very high. And we have been measuring quite a lot in the past months. We measure more than 500 samples of different types. And you can see here in this overall picture the trend of efficiency trend of typical respirator FFP3 according to EN 149, FFP2, that is to say the first one is 99% efficient, while the other one is 94%. And then the blue line is a typical efficiency of a surgical mask. You can notice it's much lower than the FFP series, and this is of course because it is intended to protect the others and not the person who is actually wearing. And then in the red curve is represented the minimum efficiency for a community face covering according to the UNI reference practice. Still it is providing, I would say, an acceptable removal of particles between 1 and 3 micrometers, while at the same time giving the opportunity to use less efficient materials. However, you can see that below the red line there are many other products that were tested. So this means that many of them were not suitable at all for the purpose of limiting the spread of the contagion. Here's some calculation. I can just show this and move forward, because the initial hypothesis was to have a flat particle size distribution in number, and by calculating the surface and the volume distribution, the particles that are larger, of course, they will be more important. This is something that we started with simply because there is no universally accepted particle size distribution, but if something different is willing to be considered, it doesn't take a long time to modify just the size distribution and obtain the new values. Those values were called ECFC, analogously to the EPMX values. In this case, of course, means efficiency of community face coverings according to the formula here below. And also some limits were put for the respiratory resistance. I would like to stress that the UNI reference practice also gives the opportunity to test, like you can see here, also full masks. No, so this means that it's not just a flat sheet of material that can be tested like in some other, like for instance for EN 14683, which for the surgical masks. We try to be consistent, however, with that approach and to use the same respiratory the velocity at 27 centimeters per second in fixing the maximum airflow resistance. And then to, one of the problems we have in front is the environmental impact of these masks. So there are different categories: non-reusable, reusable, and even biodegradable, in case the manufacturer is able to show that after some time the mask will not impact negatively the environment. And there are also some specific requirements for sporting masks. This is something very important because it is currently required by many associations also to allow sporting for people who are not professionals. However, we are still in the process of accrediting the laboratory and getting the quality mark to distinguish clearly this from, I would say, the common face covering that are sold with no specific measurements and qualification. An overall picture of what we did, you can see here the more than 500 samples tested. There were a few 84 that were surgical masks that passed the 14683 test. The yellow ones, the respirators, the same number. And then a number of green bars means that the products tested were satisfying the minimum requirements of the UNI reference practice 90, while in the case of the blue, the efficiency was too low. In some cases, you can see that it was really, really low. So they are really not helping at all in limiting the spread. And also there are several cases in which the resistance was too high. So also this, as we stated before, is something that we should be careful about. Now, one thing that is interesting, according to the title of my presentation, is to point out that this method can actually be used also for measuring other devices, like, for instance, the medical face masks. Dr. Caesar explained that the bacterial filtration efficiency is obtained by means of a biological aerosol made of Staphylococcus aureus, and this means that laboratory needed to measure the performance is a BL3, not to mention that it takes at least 2 days to get a single result, and that there is a certain variability between different labs. Doesn't matter if they are accredited or not. So if we test the surgical mask, and here you can see the data that are reported in this picture, refer to a type 1 surgical mask assessed by the University of Bologna. So we are sure that the BFE in this case was at least 95%. We can see that the number corresponding to the size for which we should measure the fractional efficiency corresponding to the bacterial filtration efficiency is below 2 micrometers. From this test, it was around 1.9. And so this means that by using this approach, we are able in less than 30 minutes to tell the producer whether the face mask is likely to pass the BFE test or not. So this is also important. Notice that if we consider the 3 micrometer size, this will not provide the correct information, because at 3 micrometers, the efficiency will be nearly 100% for this case. And this is because there is a size distribution of the Staphylococcus aureus aerosol. Even if the count median diameter is at 3 micrometers, there will be many particles with a size that is smaller than 3 micrometers. And this justifies why we should have a 95% efficiency at lower size to reach that resulting as a bacterial filtration. If we use the same approach also for assessing the performance of personal protective equipment, we can do that. Speaking of the N149, there are 2 aerosols. One is allowing the variation of the count median diameter, as here in the slide. You can see both for NaCl and paraffin oil. And also the NaCl is standard, the geometric standard deviation of the test aerosol is surprisingly wide. This is not the case of the American law, however, when I'm speaking of the N149. For N95, the geometric standard deviation must be below 1.86. So it's much narrower, it's much more monodispersed aerosol. However, in Europe, this is not the case. So these are the 2 aerosols. So what we did is that to understand what is the correlation between our test and the EN149, we measured on a typical machine that is used for making the measurement of respirators according to the standard, the actual particle size distribution challenging the respirator. And you can see here in the table here below what is the CMD, the count median diameter, and the geometric standard deviation of typical aerosols used to challenge the respirators. And the third column shows the mass median diameter, so the distribution of mass as a function of the particle size of the test aerosol that is used to assess the performance of face masks. And if we measure down to 90 nanometers by the optical particle spectrometer, as you can see from this table, we actually neglect a negligible fraction of the mass of the solid aerosol in the case of N149, while the only case in which the mass that is not taken into account by the measurement is for Code of Federal Regulation, and the amount is about 6%. But for the rest, the mass is above 90 nanometers. So this means that by measuring down to 90 nanometers, the fractional efficiency can be used effectively to calculate the expected result also for the respirator. You can see this in this example. You can see the extreme. Yes.
Can I ask you a wrap up within 1
yes.
minute? Thank you.
Yes. Yes. So you can see here, this is the example in which you have the two extreme. You can see the two extreme, and by measuring like here on the right side the fractional efficiency on a FFP3 device, we were actually able to obtain the same measurement, which is the same result. That is to say, 98% of mass efficiency. This is also valid for lower efficiencies, which is of course more difficult because the lower the efficiency, the more it is depending on the particle size. So in other words, the difference between the two is can be here. Sorry, there is a mistake. I will fix that. Is higher than 98%, the calculated initial mass efficiency. Okay, so the conclusions, what I've shown is going to provide the size resolved efficiency with the associated uncertainty much quicker than for sure for the BFE, and also for at least the initial, the full test for EN149. Contrary to 14683, the test method is able to be applied also for rigid and semi-rigid community phase coverings. It doesn't require a special laboratory for doing that. The method has been validated by other standards that have been prepared in the past, and also it is flexible enough to suit any kind of a face, not only on any kind of face mask, but also different aerosol challenge, because the rating can be changed easily by simply changing the particle size distribution. And so with this, I will be happy to take any question you may have. Here in slide 21, I would like also to acknowledge my co-workers and also the group of volunteers that worked hard for the past months at Politecnico to obtain the data that I have shown. Thank you for your attention.
Thank you so much, Paulo. Great presentation. Let's take a few minutes for bio break, and we will resume 9 o'clock in 3 minutes. Thank you. Steve, can you hear us?
I can hear you, Christine.
Okay. I can't hear Steve. Steve? Steve, we cannot hear you. Can you just log on and call the number on the Zoom? Call number on the Zoom? Yeah. Yeah. We can, it's your time. We needed to yeah, you didn't send it on my phone. It's only on my computer. You use the number on the phone. You dial the number. Right. And I did. I entered the code that said you are registered as a participant and your phone will be muted. You are the panelist. You allowed to talk. You should be able to talk. Can you just call? I've done it before 2 or 3 times. That's the only time it said that I'm registered as a participant. My phone is muted. Can you just text me or email me the number and I'll do it through my phone? Okay. You know, my email, my phone is my full name, 2395@gmail.com. Let's move on that. There seems some of the connections with Steve's phone. And Joanne, can you just check he's able to talk? And once we actually waiting for Steve's connection, probably Mitch, we can move on to some of the question and answers and while we're waiting for Steve's connection.
Okay, all right, that'll be just fine. Hello, everyone. This is Mitch McCurry, Director of Marketing here at Waterloo. We do have some questions here that were generated during our first 2 talks. One of them was differences in, does anyone know the big differences between a COVID-19 virus and the a standard flu virus? Can anyone answer that question?
Well, we should probably ask a physician about that.
Excuse me?
Can you hear me? This is Paolo.
Yeah, gotcha, Paolo.
Yeah. Well, I said that we should probably ask a microbiologist about that. But you see, the flu, generic flu, is not a specific virus. So we know that every winter we will see different types of virus. So I don't think that there can be any generalization of a flu virus. Each year is slightly different.
Okay.
Thomas Caesar speaking here. Paolo, I fully 100% agree to what you say. Flu is more representing various different types of viruses. But nevertheless, from the filtration point of view, I think there is not much of a difference, because at the end of the day, it's all particles, and the various different flu viruses will not have significantly different size ranges than the coronavirus. And therefore, I would assume from the filtration point of view, there is not much of a difference.
Okay. Okay, great. Would the humidity levels in any of this testing or removal have anything to do with, would those affect the removal of the virus as well?
I tried to answer that already in the chat here. I've seen some studies around that that did not show much of a difference. And I think the question here was also about growth of viruses. And so the main answer there is, other than bacteria or fungi, viruses are no living animals. So they cannot grow, they cannot replicate themselves without another cell, without a living body. So in an air filter or in a ductwork or in an air handling unit, they cannot grow no matter what the humidity level is, other than fungi and bacteria, as I said, where of course they can grow in a filter, for example, depending on the humidity level.
Okay. Okay. But when we're measuring these, I guess, when we're measuring the efficiency of the filter, of the mask itself, is there, are we keeping the standard ASHRAE 45% humidity levels when we're measuring these masks as well?
Well, it's depending on the test method, actually, because one for 14683 is actually asking for a conditioning at 85% relative humidity, probably to simulate the condition, which is much more humid because of our breath. At the same time, also EN 149 and also the Code of Federal Regulation is asking for a preconditioning.
Testing to see if you can hear the third speaker.
Okay. All righty. I guess we're ready. Stephen, are you ready?
Can you hear me?
I certainly can. So I guess that means you're on.
Okay, sounds good.
Excuse me. I'm sorry, Thomas. Apologize. All right, it's all yours.
Okay, thank you. My presentation is going to be on the HVAC air filter inspection, installation, and verifying the performance of the filters according to the latest CDC COVID-19 guidelines for air filtration. Next. Next. Next slide. Can you hear me?
Yeah, I can hear you. Go ahead.
Okay, we had a discussion on masks and mask performance, and we're going to talk about basically the mask for the buildings, the schools, hospitals, office buildings, and that is the V of the HVAC acronym, ventilation. Ventilation occurs by moving air and heating it and cooling it. We're concerned about filtering the air. The CDC has set a guideline of MERV 13 or MERV 14 filter if it can handle the increased pressure drop. It's important to select the proper clips, latches, and gasket to ensure an airtight seal. One of the last slides Paolo showed were masks that were being taped so they could test performance to ensure there was no gaps, no air leaks. In order to do this in the field, you need an handheld particle counter to take in-place measurements. You would measure upstream and downstream. You would also measure, put a gauge in air filter pressure measuring device, which would measure the pressure drop across the filters, and schedule periodic monitoring to ensure that the filters are operating with the right pressure drop. Next slide. Virus can spread through the air. It's generally agreed that the virus are transmitted primarily through droplets or aerosols. The average size of the particles that we're trying to capture, 2.5 micrometers, because the virus itself cannot survive by itself. It needs a host. And also it travels through what they call droplet nuclei from coughing, spitting, sneezing, and speaking. Next slide. Air contaminants and particle size. This has been already shown several times through slides prior to this, but this just gives you an example on the very bottom where you see the viruses, the ranges that they go down to 0.001 and up to 0.01. Very small. Again, these particles would not be able to be moved if the viruses travel by themselves, but they do not. They're transmitted, as we talked about, through droplet nuclei. There was also a slide showing the diameter of a human hair. It's about 100 micrometers. 1 micrometer, approximately 125,400ths of an inch. You see the other contaminants as well. Air filtration has never been under such high scrutiny. I've been asked to go into various rooms in hospitals, surgery suites, isolation rooms, and measure the particles to see if they're getting the performance required for the application requirement. Next. There's basically a 3-step process for in-place air filter testing. Step 1 is to select the proper filter. Like masks, there's a lot of research on masks, what type to use, what not type to use, what will protect you, what will not protect you. And recently they're talking about wearing 2 masks to ensure that you get a tighter fit. The CDC guidelines require MERV 13 filter. This requirement is under a independent ANSI ASHRAE 52.2 test report using MERV, which is the minimum efficiency reporting value. You want to also examine the construction of the air filters for engineering approval. Many filters may have a MERV 13, but they will not hold up under your system due to airflow velocity or high humidity. You may need to have a metal cell filter versus a non-supported filter, depending on the application. Basically, it's not a one-size-fits-all, but when you find out what type of filter you need, the second step, next slide, is to obtain an ANSI ASHRAE 52.2 2017, the most recent ASHRAE test standard, a test report, independent test report. Next slide. This slide shows you the basic air cleaner performance report summary, and it covers the device, the type, who the manufacturer is, the laboratory data, test conditions, airflow rate, temperature, relative humidity, initial pressure drop, final pressure drop, resistance to airflow test resistance, initial, final, and finally in the very bottom of the report, you'll get your minimum efficiency reporting data. It's composite average of 3 ranges, E1, E2, and E3. You get a resistance curve, a fractional efficiency curve, and dust loading data. You want to make sure you obtain all 3 of these sections in the test report. Next slide. After determining your filter is the right efficiency, you need to install this filter. Just like putting on a mask, If it's not airtight, you're not going to get the performance that's required. We recommend using an LED flashlight upstream. You'd have a technician upstream and scan the filter bank. Someone would be downstream, marking the sections where the light shines through. You would then seal by using gasket and caulking material to ensure you have an airtight fit. Experience shows that a majority of the leaks are found due to the poor framing and in the corners of the filter. Here's an example of a very poor structural filter bank using a non-supported pocket filter, which is referred to bag filters in the industry. This is in an actual hospital, this filter bank. Next slide will show you a poorly installed air filter. Again, this is in a hospital. The filter didn't fit properly, so the technician just smashed it into the frame instead of getting it sized for an airtight fit. You can see the gap in the bypass. Regardless if this filter was a HEPA filter, you would not get HEPA filter performance when the filter is installed poorly. This is an example of a rigid V-cell arrangement. I think go back one slide. Right. This is an example of a good structural filter bank. Yeah. This filter bank has metal cell sides, aluminum separators. They are not HEPA filters, but they're designed in the same way that a HEPA filter is designed, using wet laid media with aluminum separators. This is an example of a good structural filter bank integrity. Next slide shows you a V-cell arrangement. These filters are used in high velocities. They run at a much lower pressure drop and give you a much longer service life. Again, these are rigid filters, and this is a very good installation. Next slide. It's important when the filters are gasketed that the gasket on the filter is correctly installed. Note the interlocking corners on the filter frame. You want to have the gasket completely seal all four sides using a dovetail or interlocking gasket on the corners. Next. Cleaning the filter frames before the filter is going to be installed. You want to make sure you vacuum, use a wire brush and vacuum out all the debris to have a clean metal filter frame before installing the filter. Next slide. There are also side access systems using a V-bank or a straight bank. Here is a V-bank, and you can see there is no gasket on the door, and you can see where the filters come up against the door and there's leaks and bypass. V-banks, as mentioned earlier, are used for high velocity systems. It will typically double the filter life cycle of a HVAC system. Next slide. You want to check for missing gasket material on the frames. You want to use a wire brush and vacuum out and apply the gasket to the entire frame. Next slide. After applying the gasket and caulking, double check the air filter frames, the filter tracks if it's a side access system, the doors as well. You want to repeat step number one after doing all this work for sealing up the HVAC filtration system, whether frames or tracks. You want to measure twice, cut once. Next. For the installation of a V-bank filter housing, if spaces are needed, make sure the spacer has a gasket. And when you put the filters in side by side, you want to make sure you put gasket tape on each side of the filter so you have an airtight seal between the filters in the track. Next. If it's a frame system and you put the filter straight into the frame, you want to make sure you use 4 clips per filter. You want to also check the air velocity using the pressure drop on the gauge that's mounted on the unit itself. You want to check the initial pressure drop and mark that and record that. This pressure drop at the same velocity should be the same as the manufacturer's data on the 52.2 test report in the manufacturer's literature. It's important that you mark down the initial pressure drop to determine when the final pressure drop is going to be used to change out the filters. Next. The installation, you need to install filter gauges. There's a manometer with the use of fluid, as you can see in the picture to the right. You want to, again, measure that pressure drop clean, mark it down, make sure the sensor locations are properly installed upstream and downstream according to the manufacturer's recommendations. You want to maintain calibration records as well to determine when it's the optimum time for your filter changeout. Next slide. This is a dial pointer gauge using measured pressure drop, same as the fluid manometer. This is a magnehelic, and it measures static pressure in inches and water gauge. This measures a 1/10 of an inch. Next. Measuring and monitoring pressure drop across the filter bank provides the necessary information for optimal filter changeouts. Filter changes should be based on pressure drop. Recording this pressure drop data will give you the life expectancy of the filter. Monitoring the pressure drop, which is measured in inches of water gauge, will assist the engineering department with the estimated cost of the air filters while in operation. Note, it's estimated that 75 to 80% of the cost of HVAC filters is in energy consumption. Next. There is going to be a ASHRAE guideline for the energy use on HVAC air filters. They're trying to model it similar to the SEER, Seasonal Energy Efficiency Ratio, provided by the government using the energy guide. This will give you an example of your estimated energy cost, how much you pay a kilowatt, how many hours you used over the course of a year, and this will give you your estimated energy cost. Next. Using a handheld laser particle counter, you can take readings upstream the filter bank and then downstream the filter bank. Using ASHRAE 52.2 standard table 12.1 to determine your actual performance. The objective here is not to mimic a lab test to determine the fractional efficiency of the filters in the ranges, but to see if you're getting the performance. This is table 12.1. Showing the minimum efficiency reporting value parameters. It shows a composite average of size, particle sizes in percentage in their ranges. Range 1, range 2, and range 3 are at the top of the chart, top of the table. To the left, you'll see numbers MERV 1 to 15. We'll go down to MERV 13 and go back. Down to, on the left-hand side, you go down to 13, you slide to the right, and you go to range number 2 that we've been talking about for the past 2 presentations, 1 micrometer to 3 micrometers. You want to remove an approximate 85% of that range when you do your test. Next slide. You want to make sure that the instruments you're using are calibrated. Ensure that you have a certificate that the instrument, again, has been calibrated on an annual basis, and get training, professional training, to use the instrument correctly. You want to collect the data and communicate the results and any risk if there is. Next. The ranges you'll have on most particle counters that handheld would be 0.3 micrometers, 1 micrometer, and 5 micrometers. Next. I think it was President Reagan that made the phrase very popular that you trust everyone, but verify everything. Verification is important. Documentation supports your verification. Depending where you are in your career, you'll determine how important documentation is. You want to document the in-place particle count measurement. You want to schedule periodic in-place monitoring. to effectively manage the HVAC air filtration system. Measuring, monitoring, and managing. If you're not measuring, you're guessing. Next. We talked about how small these virus particles are, even being transported by bioaerosols, droplet nuclei. They fall into the range of about 2.5 micrometers. For those in America, we still use the inch pound. 1 micrometer is approximately 125,400ths of an inch. You want to ensure you document all your records. As I've shown you in these slides, you want to use photographs to support written reports. As the expression goes, a picture is worth 8,000 words. And important, remember the 3 M's: measure, monitor, and effectively manage your HVAC air filtration systems. Next. Thank you for your attention. Hopefully I got through that in time, and we can open up for any questions.
That was perfect, Stephen. Thank you very much. We really appreciate it.
You're welcome.
We do have a few more questions here that we have to ask. So I'd like to address this to the full panel. When we're talking about community masks, and I think we use that in this presentation quite a bit, not necessarily in yours, Stephen, but in the other two. What we're talking about in those masks, are we only talking about mechanical filtration when we're in those community masks, or are we talking some other mechanism that's going on there? Anyone?
This is Paolo. I answered in the chat, but I don't think so. I mean, a community face mask is, we have seen so many different things. So there is no fixed definition for that. So no, the answer is whatever.
Okay. Okay.
I 100% can agree, Thomas, here. What Paolo said, the nature of the community mask is that it is undefined. So, as Paolo said, it can be everything and nothing.
Yeah, yeah, I guess you're right. Yeah, that's for sure. Specifically, I have another question for you, Paolo. On your graph, I was watching. I was listening fairly carefully, and I was wondering, how did you account for leakage of the mask in your graph?
No, in every test method assessing the efficiency, and we're speaking also of 14683 or EN 149, or also the Code of Federal Regulation, the mask or the material must be sealed. Okay, so when measuring the efficiency, this is something that does not take into account any possible leak. This is taken into account only in the standard, for instance, EN 149, because there is a specific test in which the mask is worn, and then there are some activities that are performed, and there is a measurement of the particle concentration in the small room where the activity is performed. And then there is also, at the same time, there is a measurement of the concentration between the mask and the mouth. Okay, so this is a specific measurement. Of course, this can be done like it is done in EN 149, but I don't think that given the situation, we can expect the community face coverings to be tested in that way, simply because we don't even know exactly what is the measuring method for the efficiency. So this is for sure of interest, of practical interest, but I doubt it will be possible to give that information till we don't have a common ground for efficiency and therefore resistance.
Okay.
I have a question, if I could, Mitch, ask the first two speakers. in the United States, the National Institute of Health Director, Dr. Anthony Fauci, has come out and talked about how masks need to be, what they talked about in the first two presentations, fit properly. They didn't for a year. They just said, first he said, don't wear a mask, then wear a mask. Now the latest is wear two masks. Is there any data, any science behind wearing two masks, especially for people that have COPD and respiratory issues, wearing two masks versus wearing one mask? Is there a benefit to wearing two masks?
Good point.
Well, the point in wearing two masks is that the second mask probably can squeeze the first one against the face more than just wearing a single mask, I guess. For sure, yeah. Then it depends, as we know, also on the nature of the mask, because if it's non-woven material, we can expect the efficiency to increase. But if we have two masks that are made of the same fabric, then the efficiency of the fabric will not increase appreciably.
Right. He wears a surgical mask, and then he uses one of his, like a lot of people wear these fashion masks with, logos on them, cloth material. There's no testing data on it, but it says putting that second mask over the surgical mask will make the surgical mask air fit tighter. But again, I don't know if that's accurate, if that's any science behind putting a cloth mask over the surgical mask will give you a better seal.
It depends on the elastic. No, if the elastic is very strong, then it may happen that, yes. It depends on, it's not a question of the filter material, it's a question of the strength of the elastic.
Right, the fit, to get the tight fit. It just seems to me that after 1 year, they're talking about how important the fit of the mask is, where they didn't even mention it. They just said, wear a mask. And now we're getting into all the specific surgical mask, N95 respirators, et cetera, et cetera.
This is Bob McElvain. There is some recent research where they're actually testing the efficiency of one mask on another. And as you might think, if you put the surgical mask on over the cloth mask, you don't do anything. But if you put the cloth mask on over the surgical mask, right, and it does cause a tighter fit, then they're showing some fairly substantial efficiency increases for a surgical mask. But it seems like it's all haphazard.
Right. That's exactly. It seems haphazard. That was the reason I was asking you gentlemen, experts in the field, if there is science behind it. I am from Boston. I'm from New England, as you can tell by my accent. But I am actually from, when questions come up from Missouri. Missouri in America is the state that says, show me. I'm the show me state. I want to see the data. I want to see the science so I can feel comfortable and confident wearing the right mask and having it worn properly.
Well, I'm glad that Bob McGovern just mentioned. So if you have the surgical mask underneath fashion or community mask, you do have two functions. One is you improve the efficiency, and another way you improve the tightness. So this seal will be much improved. So based on these two facts, it seems it's add-on performance when you wear two face masks together.
But what about breathing? It's much difficult to breathe over a long period of time wearing just one mask, but wearing two it's much more. At least for me, I don't have COPD, but I do have asthma and I do have a little bit of breathing difficulty. So when I wear two masks, it's a strain on me.
We do have, I think, Wendover, are you on the phone? Actually, they have a lot of experience on the face mask, both community and also functional face mask.
Yes. Hi, I'm here. I could probably address this because we've had a lot of questions recently since Fauci brought up the concept of double masking. What we've advised, our product is VOG mask. It is a community mask. However, over the past 10 years, we've subjected our product to workplace respirator standards because there were no community mask standards. So we've previously held we currently hold KF94, We had China KN95, CE FFP2, and of course we test against NIOSH workplace respirator CFR. So we have been advising our product is a 4-layer mask. It has 2 layers of filter in the middle. So when people have said, is it necessary to double mask in a VOG mask? We've said no. The purpose of double masking is, one, to, if you put a surgical mask under a cloth mask, which has no filter media, no highly efficient filter media, then you are adding to the efficiency of the mask. And as Bob McIlvaine just mentioned, you can also improve the fit by putting a cloth mask over a surgical mask. What we've run into, this is not necessary in a VOG mask. The filter media is built into the structure of the 4-layer mask. And we feel that if you put a surgical mask under it, you're risking elevating the breathing resistance outside of the safety range, because we're measuring 0 to 30 milliliter column height of water. And we're already measuring at 10 in a VOG mask without a surgical mask under it. However, this is the last thing I'll say, and I know this will be interesting to the community mask discussion, where you, if you're going to go get a vaccine or go to a medical appointment and the health provider, for example, my UCSF Medical Center, if I walk in a VOG mask, they have no idea if there's a filter media in the middle of the mask or not. So they may say to you at the front door, you have to wear a surgical mask. To which I say, surgical masks do not fit tightly on me. I'm a very small person. May I wear the surgical mask over my VOG mask? And they say, certainly. So we're, just starting to address these questions, and the double masking issue has been very present in the last week. And previous to that, as Bob mentioned, the fit is a huge issue in terms of community mask discussion today.
Thank you. That's a very good answer. Thank you.
All right. Thanks very much. So there was another question, and I just wanted to kind of run this by the group as well. On the disinfecting of KN95 masks, can you disinfect those with alcohol, 70% alcohol and or steam, both? And these are specifically with the reusable masks, or the disposable masks, I'm sorry.
This is Paolo.
Okay.
Yeah. Well, whatever you do to disinfect the mask, especially if you use alcohol, you are very likely to affect the electrostatic charges on the material if they are present. So if you, especially for respirators, you can expect the residual efficiency to be much lower than the initial one. In terms of penetration, this is somewhat even more relevant, because this is from 95 to 90%. It means that the penetration doubled from 5 to 10%. So it's any disinfection is not leading to. I mean, it's providing a final result that is affecting the efficiency. However, as in the case of we discussed before, some protection is better than no protection.
Right. Yep.
This is the only way. This is what you have to do.
Okay. Makes sense. One more question, please. So we have HVAC systems that are set up for schools, and then we have HVAC systems that are set up for commercial buildings. How do, and if you answered this, Stephen or Thomas, I may have missed it, but I was just curious as to how do they vary?
How do the school systems vary from office buildings, say
Right,
hospitals?
right.
Okay. Office buildings typically are like schools that typically will have a one-track system, meaning a filter before the heating and cooling coils, and that is basically it. Whereas in a hospital, is required to have two stages, one upstream the heating and cooling coils, and then behind the heating and cooling coils and the fans and all the equipment are your final filters. So that is the basic difference between schools, office buildings, and healthcare facilities. The one-track system can be a frame or a side access versus a hospital healthcare facility having two separate filtration systems.
Okay. And then in the hospitals obviously have several different filtration systems depending on where you're at, correct?
Correct, and different degrees of efficiency. Pre-filters, they spell out a MERV 7, final filters, MERV 14, and then if you have surgery procedures in 3 different categories, you're required to have high efficiency particulate air filters, HEPA filters at the discharge right in the room itself. Bone marrow transplant, organ transplant, and orthopedic surgery would be those requirements that ASHRAE recommends HEPA filtration.
That's interesting, very interesting. I'm not sure whether everyone on the all of our participants really understand that the levels of filtration that are needed there in a hospital. So
yes.
Okay.
And I'll just say this, it's not a one size fits all. There are different types of filters. I showed you a non-supported bag or pocket filter, a rigid cell filter that looks like a HEPA, and then the latest filters, they come up with a V design. Typically a final filter, a 24-24-12 filter in a box would have 50 square feet. The wet laid paper media one I showed you would have 100 square feet, and the V cell, the third bank I showed you, the third slide, showing a V-bank filter would have 200 square feet per filter. So this gives a lot more surface area for the air to go through in the same 24-24 opening at a much less pressure drop. So it lowers your energy costs and extends your service life, less disposal, less shipping, handling, et cetera, et cetera.
Okay, all right. Kind of going back to something a little more simplistic on this last question is, so what we have is we have masks that are rated at PM1, and just for clarification, those PM1 masks, do they actually stop viruses, or how do those actually work to prevent coronavirus from getting into your system, so to speak? Anyone?
That would be Paulo or the first speaker. I wouldn't be able to address that.
Paulo?
Sorry, I missed part of the question. Can you repeat that? Sorry.
Okay. So we have masks that are rated PM1. I think you had indicated those, and I think also Thomas had indicated those in his presentation. PM1, it would seem logical that PM1 would stop, 1 micron particles, whether they be viruses or bacteria. How can they really be? Are they really stopping viruses, or are they stopping? Where are they stopping?
Okay, so well, the face masks actually are not rated this way. PM1 is the ISO 6. So
Paulo, we can't hear you.
Sorry, can you hear me? Can you hear me?
Right.
Yes.
Yeah.
Okay, so I said that the EPM1 filters are classified according to the ISO 16890. This is not a classification for face masks.
Okay.
What I mentioned is the ECFC is something that is different because it's taking into account a size range between 1 and 3 micrometers, while in the case of EPM1, the size range that is considered is between 0.3 and 1 micrometer. So the point here is that when you say stopping the virus, the problem is to to know actually where the virus is heading and whether it's in the smaller or in the larger droplets.
Right.
If we assume that there is a size distribution, like it is very likely to be, then the higher the efficiency, obviously, and the higher the chances that the virus will get trapped into the filter. So an EPM1 80%, it's a high efficient filter in removing most of the particles that are probably containing the virus. And
Okay.
for all filtration, as in all filtration problems, however, this is a statistical approach. So, of course, if you use a higher efficiency filter, the chances to capture the virus will be higher and higher. However, it's unlikely that we can keep all the houses and offices like HEPA with HEPA filters like a clean room. No, so but still it is a very high protection rate by installing EPM1 80% filter, which is about equivalent to MERV 15, I would say, filters.
Yeah, I'd like to also pose the question of temporary versus permanent capture. And since we're dealing with droplets here, and droplets on the interior of a mask, for instance, or the interior of a filter, are either going to evaporate or separate, do we need to analyze the permanent capture versus the temporary?
Right. No, I agree. So thanks for answering those questions. We appreciate it. We do want to remind everyone for today that our 2021 CFSS opening ceremony will be March 9th from 8 to 10:30. And we have several global leaders in filtration that will be attending and giving speeches, giving a talk as well. Next. And our introduction to global filtration will be our first Wi-Fi training course from 8 to 9:45 on that day. And our panel discussions will be from 10 to 10:30, and they will be on new trends and opportunities for the filtration industry. We thank